All right, we're gonna get started as people trickle in. So this talk is called "People Are Weird." My name is Andrew Farah. I'm Density's CEO and one of its co-founders. We've been working on counting people for almost 5 years now, and I thought I'd show you some of the weird stuff that we've seen along the way. All right, so on the left is the agenda. I promise to rip through these quickly, but these are just some of the strange things that we've come across. So high level, the population is growing into a fixed amount of space, which is another way of saying like we're not making more Earth. So like Earth remains the same, but then like we're like constantly growing the population, and by 2040 we should have roughly like 10 billion people. So eventually we're gonna have to figure out how to make better use of the space we have as opposed to constantly building new space. This is actually a really cool chart I'll add in the deck. Just a reference that you can find this chart. There's a really, really cool place called World of Data. Okay, so people are super weird. This is what we've seen, what our device has seen out in the wild. We're deployed in many, many locations around the world, and we've seen some really strange things. People walk in different directions. They bring stuff with them, so giant televisions or whiteboards. It's actually very hard to make sense of what is human in this scene and what is a television. And then in some cases, people actually hide beneath things. This is called an occlusion problem. So the hinge, it turns out, is actually very hard to figure out how to separate from the human. There's all sorts of stuff, everything from giant packs of people. It turns out that plates look a lot like heads. So in this particular location, we were dramatically overcounting. It's a very popular cafeteria. We count something like 5,000 people into this one cafeteria through a number of different doorways. And then sometimes in the middle of the night, well, regularly in the middle of the night, giant trash cans roll through or beneath these devices as people clean up after employees. And then sometimes they're dogs. We don't count dogs, although we could probably count dogs. We don't like offer that as a service, but it is important to call out that sometimes they're non-human, and when they're non-human, then obviously we need to make sense of just what is human. Okay, so what is density and how do we know what is happening? Okay, this is this is like the coolest thing that I've ever seen. Our industrial designer built this, and it's sort of shows all the parts. It's a 4-board solution. The thing has 800 subcomponents in it, and it's designed specifically to use infrared lasers and some advanced machine learning to anonymously count people. And then we provide the entire platform and analytics around making sense of occupancy inside of corporate buildings. So we help a lot of very large corporations, many of them in the Fortune 1000, make better use or essentially better understand how their buildings are being used so that they can make more efficient, automate, or otherwise reduce cost to these really large corporate holdings. And we do so anonymously. So the device gets mounted above a point of entry, kind of like a shower head. And we support any single or double entryway. And then this is what it does. So all those depth videos that I showed you before, completely anonymous. You could stare directly up at the device, but we'd have no idea who you are. But this is what's happening on board each of the devices. And this is one of the reasons we've been able to figure out that people are actually really weird. It turns out that people being weird is why counting is hard. I should say one other thing. The difficult thing with counting people and making sense of human behavior or occupancy inside of a building is actually that you have to categorize all the things that are non-human in order to make sense of the things that are. And so we actually thought it would be mostly just about counting people, but it's actually about counting all the stuff that's non-human and then deleting it from the scene. So what you can see on the right is actually the processed image or the processed depth set, which is getting rid of the floor, the walls, any objects that people are carrying, and so forth, so that we can increase signal and focus on count. Okay, I'm going to tell you a few stories. So I did not know this, but it turns out that 40 to 60% of all entrances to an access-controlled door actually look like this. So this is someone who badges in, and then shortly after this person badges in, another person shows up and walks through. And this is unauthorized access. I didn't know this is a problem, but it's a really big problem. And for years, something like easily like 20 years, large corporations have been trying to solve this particular problem ever since access control became a thing. This is mostly polite employees holding the door for other employees, but at the end of the day, policy, the policy of everyone badging in is really, really important to the physical security. So people invented some things to stop that. If I could see you all, I would ask everyone to raise their hands if you know what a people leader is. It is not this, nor is it this. It's actually this, and I really like this photo, partially because the pink is weird, the drop shadow is really awesome, and her posture is crazy. But this is a people leader. If you live in New York, then you've probably seen these. These are expensive, they're big, they're clunky. You can't, you wouldn't move them, and they're sort of a way to ensure that people go through one at a time. Man trap. This is not a man trap. That's a bear trap. This is not a man trap, although that's a really good stock photo that I need to figure out how to use in a presentation like this. This is a man trap. These things are like $250,000 each. They're typically at airports, and their ways also to force one by one entry and exit, or sort of no greater than 3. Some of them are a little bit larger, but it's to ensure that they know exactly how many people go through a point of entry. So with density, so there's a device, a density device that's installed on the other side of this door. So same exact video, and we actually we worked with a number of firms, but one in particular was really excellent, and actually designed this remarkably simple system that compares our count data with the badge reader. And in real time, if there are 2 people who enter, which is what density is counting, but only 1 person who badges in, then that is unauthorized access. And it kicks off this, they use our API, and in 700 milliseconds, so almost real time, it kicks off this process where it takes and turns on the surveillance video that's pointed at that door and flags it as something to be reviewed by the security team. Again, this is kind of a soft alarm system, so it's not something that's really trying to get people in trouble, but rather ensure that they don't have unauthorized access. Oh my God, the television. Okay, so we will periodically do reports for customers, and we were working with a financial institution that was trying to understand the usage of several of their rooms. And so they installed density devices above these points of entry at each of these conference rooms, and we measured over a period of time, and then we did this fun little report, and we said, we're not exactly sure what's going on, but it looks like only 2 of all of these rooms are actually regularly used. And they said, which 2? And we pointed out which 2. And they said, oh my God, it's the televisions. And we were like, oh my God, what does that mean? And they said, well, those are the only 2 rooms that actually have televisions. And we think that the reason that those rooms are the ones that are being used so heavily is because they have the appropriate technology for whatever the purpose of that team was. So our recommendation to them obviously wasn't put televisions everywhere. It was instead that like once you have actual usage data, you can start to really deeply understand other contextual information or observational information, and then you can make adjustments to your space. So I'll tell one other brief story before I move on to the next one, which is we had a similar circumstance with a large consulting company, and they did a similar deployment in call it a half dozen rooms, and they had one room that a team of 25 would regularly book. And we measured usage of that room. And it turned out that 70% of the time, it was being used by fewer than 4 people. The consulting team was like blown away, first off. They immediately sort of expanded to, I think they expanded to something like 50 or 60 new rooms. And then they changed their policy internally so that it couldn't be booked without being actually used. So once you have some of the hard data, some of what's actually happening inside of a building starts to become really, really interesting. Yeah, so I'm actually going to fly through these. All right, 10.9 billion square feet. So in the U.S., there's 10.9 billion square feet of leased or owned corporate office space. 4.4 billion of that is vacant but paid for. Which amounts, I mean, and it looks something like this. I mean, like this is why there's so much space. I mean, these organizations have remarkable real estate portfolios, and when you cum it all up, the space is so significant, but the usage is actually the utilization is rather low. So in the U.S., only 41%, something like 41% of all space is vacant but paid for, which amounts to $150 billion spent on space that's empty. That's crazy. And also we think that it's conservative. So we think the numbers are actually closer to 300 billion in the US, and the percentages are actually rather neat. They're about the same in all developed nations. So people count and occupancy data is the same in all languages. And we've seen that quite a lot of adoption internationally, largely because in Europe, the wasted space, like the empty but paid for space, is like 36%. In Japan, it's 46%, like empty but paid for. I think China is probably the only outlier, which is something like 29%. And I think population density has something to do with that. But the point is that this is a massive global problem. We've invested trillions of dollars in physical space, essentially on an architect's guess, which is crazy. Okay, anyway, COPA. Whoops. So COPA is, so if I could see you, again, I would also ask you to raise your hand if you know what COPA is. I did not know what COPA is. It turns out it's the Child Online Privacy Protection Act. COPA it's why if you're under the age of 13, you can't watch YouTube or a certain type of YouTube. So if you ever encounter those things where it asks you about your age, it's in large part because of a federal law called COPA. And COPA, every 3 or 4 years, COPA is updated based on evolving technology. And what's coming is COPA does not allow, without the consent of a parent, the identification or tracking of a child under 13. So as cameras start to become more intelligent and start to be able to identify demographics or do facial recognition or return visits or whatever else it might be, this is going to be something that's really interesting to see how they deal with COPA. Flipping the bird. Oh yeah, sorry, that's the statute. So in 2016, we actually did a study in a firm in San Francisco where we have an office, and we were working with a customer, and we wanted to understand the impact of telling an employee that a camera was staring at them. And so we took a very early prototype. It was a giant box. It kind of looks like a huge pizza box, deep dish. And we put it above a point of entry, and then engineers showed up, these engineers, which I'm going to show you in just a second. We said, it's a camera, and it's looking at you, and it can identify who you are and where you go. And this is what the engineer did. And what was really, I mean, we started laughing. In fact, when we start laughing, you'll actually see he turns around because we're about 10 feet behind him. We started laughing, and we said, we'd love to show you what the device actually sees. So he came over, we showed him what depth data actually looked like, and we explained how our algorithm worked. And he started laughing, and he said, man, that is so cool. And it began this discussion or dialogue around reasonable expectation of privacy, especially in areas where you're having, a conversation about mergers and acquisitions, or you're dealing with intellectual property. When you're going into a conference room or you're going into a space that you feel like you should be able to have a private conversation, being monitored is something that you don't want to necessarily have to worry about. Okay, the last one, and then we'll open it up for Q&A. So there's a company we work with, just to give you a sense of scale. There's a company that we worked with, that cafeteria that I mentioned earlier, where we had plates that look like heads. There are 5 points of entry to this one cafeteria. Over the course of 90 days, we counted 515,000 entrances and exits to that one cafeteria through 5 doors. In fact, it was so many that when we showed that to the client, they didn't believe us. So we showed them the accuracy, and it was something like 98.77, 97.62, 98 point whatever. We always do accuracy on a door-by-door basis, and we showed them showed this to them, and they said, "Oh my God, maybe that's why the hinges are breaking." So again, like it just puts into context, like the rate of entry and throughput that people have inside of buildings is so much bigger than people realize. And it's really exciting to be able to be a part of generating some of that data. I'm actually going to skip through some of this, but these are actually just some like fun applications that we build. So this is Density's mobile application. We work with a hotel and airline that allows in real time to staff up based on needs. So when there's a lot of people, you can add people or add resources to clean or add more food. Yeah, that was a random slide, but I think generally the takeaway is that space is really big, people are really weird, and that's totally normal. Yeah, also like our thesis is that you really shouldn't build any space without knowing how it gets used. Okay, thank you very much for attending, and I'm happy to address or answer any questions. Also, if you would like to follow up with any of our team outside of this presentation, you can just send a note to sales@density.io. Okay. So one of the questions is, do you think the conversation around privacy and anonymity is changing? Are companies more or less lenient? I think Cambridge Analytica was kind of a watershed moment, and people are starting to have conversations around what reasonable expectation of privacy should be. I also think that we will often tell customers if they're comfortable putting a camera inside of a conference room or above an engineer's desk that that they should do that. But if they value privacy, or if their employees value privacy, then we're happy to have a conversation with them. And I think one of the things that's interesting is that depending on who you talk to inside of an organization, it can change what the response is. So if you talk to a policymaker, a head of, call it the management team, for instance, they'll say, well, we have a policy that allows us to track our employees. But then if you sort of go down to the employee level, you'll actually hear really crazy stories like, oh, the seat sensors, yeah, those seat sensors that were beneath our desk, we actually ripped them out and tossed them in a toilet. Now that's kind of funny, but people don't really like being tracked, and that's culture. And so often we've seen this concept of privacy, people will try to scale certain systems that are a bit more invasive, and as soon as they do, they start to run into this culture stealing. Yeah. Another question was, do you have any recommendations on the easiest types of problems to solve with this technology? Any easy wins? Yes, there is an easy win. If you own a bar in Manhattan, Kansas, we can help you deter the fire marshals from citing you for being over capacity. That's actually a real example. There's this amazing bar and this amazing bar owner that we work with in Manhattan, Kansas, who essentially uses density to ensure in real time that she's not over capacity and against policy. It helps her avoid citations, and it helps her also ensure that that she doesn't have to go to court to fight the ticket or whatever. But yeah, that's more on the long tail. I'd say like high level, if you have a lot of office space, we can tell you which 40% of your office is not used but paid for, and we can tell you very quickly. We can also help your employees see how busy certain spaces are in real time using Density's mobile application and integrations with Slack, which is super cool. You can literally just say, hey, Density, is the cafeteria busy? Or is that room available? And it will just tell you if it is. We can even notify you when it's quiet. That's probably my favorite feature. So you can just like get back to work. Another one is anti-tailgating. This one is a bit more involved, but if you're really interested in mitigating any tailgating that happens on your building or at your building, we can help you solve some of those problems. Okay, next question. Can you explain how machine learning works for getting this type of data? I know it's a buzzword, but what does it actually mean? Yeah, okay, so all the depth videos that I showed you earlier, I think that'll be our last question. So all the depth videos that I showed you before, what you do, or at least what we do, is we gather contiguous depth data, and then in the very early days, we were actually painting by hand. This is an arm. This is a shoulder. This is a head. That's a manipulated object. That's a large manipulated object. That's a dog. This is a wall. These are doors. And when over time you generate tens of thousands, hundreds of thousands of these individual, they're called labeled frames, which is simply a static image with individual labels, small categorized labels of the arms, the heads, the manipulated objects, and so forth. And then you take all of that. It's called supervised learning, where a human is involved in explaining to a computer what the hell is happening. And then you take all that data and you put it into a model, and you build a machine learning model. And that machine learning model takes in all of that learning, all that supervised learning, and it spits out a result that is either really performant or is not performant, meaning it's really accurate or it's not really accurate. And the way that we know that is by comparing it to human annotated events, which is simply a human saying that was an entrance, that was an exit, and so forth. And so we get really granular accuracy reports as a result of, we can get very granular accuracy as a result of the machine learning model. I'm also not the smartest person on this, and there are all sorts of really awesome engineers. So in the event that you would like to talk to someone who is steeped in machine learning, deep learning, and some of the other techniques that we use to count people, we're happy to put you in touch. We have some really remarkable engineering talent. Okay, I think that's going to wrap us for today. Thank you very much for attending, and I hope to talk to you soon.